Okay, so I was just about to introduce an example of a continuous probability distribution, and I'd like you to consider the distribution of random variable x, where x is going to represent the time spent waiting for a bus, let's say. You get to the bus stop, and the buses run, say, every 15 minutes or so. You may get a bus in 1 minute, you may get a bus in 3 minutes, or you could really get a bus, in 1.5 minutes or 1.723 minutes, or theoretically, the time that it takes you for the bus to arrive could be anywhere between, say, 0 and 15 minutes. So my probability distribution then, we can start with 0. And I know I don't have it at the origin. That's okay. I'm going to put 0 here on my x-axis. And let's say 15 minutes is the maximum. Now, so x could take on the value 0, 15, or any number in between. It doesn't have to be an integer value. What would this probability distribution look like? Well, it depends. Okay, really, if buses run approximately every 15 minutes, it might be just as likely to take 1 minute as it does to take 13 minutes or anything else, or 13 and a half minutes, whatever. And this might be a good example of a uniform distribution. Okay, this is called a uniform distribution. This is an example, it's probably the simplest example of a continuous probability distribution. Another way to say that is it's a probability distribution for a continuous random variable. And what this is a horizontal line at the top of this probability distribution. And this indicates that all values between 0 and 15 are honestly equally likely. Okay, no, you're not any more likely to have to wait 3 minutes as you are 4.7 minutes. And we can find the probability, we can calculate probabilities then for different values of x, different ranges of values of x, using this probability distribution and a little geometry. So what I'd like to do is to start by, for example, let's calculate the probability that x is greater than 8. Well, 8 occurs right about here. It's a little closer to 15 than it is to 0. I'll put an 8 there. And the probability that x is greater than 8 is going to be found by finding the area between the probability distribution curve. This is called the density curve. Okay, this is called a density curve. That's the case for any continuous probability distribution. And what I'll do is I'll find the area between the density curve and the x-axis. It's a rectangle. That'd be 7 units long. And then the question becomes, how tall is it? Well, that's a great question. I have to go back to the fact that the total area under the curve, the total area under any density curve, under any probability distribution is 1. Okay, so if this is 15 units wide, to find the total area under the probability distribution, I have to take the width times the height. So 15 times 1 over 15 gives me 1. So the height of this curve has to be 1 over 15. And then when I go to calculate the area under that curve, I've got 7 units wide by 1/15 of a unit tall. So to find the area, 7 times 1/15, which is 7/15. Now this concept of using areas to compute probability is going to transfer over to other continuous probability distributions, some other specific types of continuous probability distributions.